Hi everyone, so let's solve today's daily Lead Code challenge question. I will set it 20 minutes timer. Okay, this is easy, so it should take just a few minutes. Let's read the question. You have a bomb to defuse and your time is running out. Your informer. So okay, I have a bomb to defuse and my time is running out. Okay. Your informer will provide you with a circular array code of length n and key. Okay, so this is a circular array code 545714, and this is a key. To decrypt the code, you must replace every number. I should replace every number. Okay, all the numbers are replaced simultaneously. Okay, so if k is greater than 0, replace the ith number with the sum of the next k numbers. You mean if k is greater than 0, so k is greater than 0 here, right? So 5 should be replaced with ith number with the sum of next k numbers, next 4 numbers, right? 7, 8, 19, 11, 12. So 12. And if k is less than 0, then ith number should be replaced with the sum of previous k numbers. Okay, if k is 0, then replace ith number with 0. Okay, and for 7, what should I replace it with? Sum of next k numbers, right? So there is no any next 3 numbers here, so what should 7 be replaced with then? Oh, because it is a circular array, so it should be 1 plus 4 plus 5, right? 5 for 19. 5 for 19, yeah. And then this would be, for 1 it should be 4, 5 and 7. Interesting. So this would be 7, 1, 4. For 7 it should be 1, 4, 5. For 1 it should be 4, 5, 7. And for 4 it should be 5, 7, 1. Yeah. Our code is circular. So the next element of code n minus 1 is code 0 and the previous element. Okay, given the circular array code and return the decrypted code to defuse the bomb. Okay, so it's not that hard, right? So let's see. So if it is 0, then everything will be 0. If it is minus 2, then it should be previous two numbers, right? So it should be, for 3 it should be 9 4, for 9 it should be 4 2, for 2 it should be 3 9. Okay, and let's look at the constraint. Constraint is n is equal to code that length and n is equal to code that length, and 1 is less than or n is less than or equal to 100. I'm streaming, right? Yeah. 1 is less than or n is less than or equal to 100, and code I is less than or equal to 100. So and k can be minus 2 and minus 1. Okay, so let's think about how I can do this. So basically for every number I have to look at other 2 3 numbers. For every number, and k can be any big number, you know. K can be n minus 1 to n minus 1. Oh, okay, so it means 1 2 3 4. So if code is of length 4, for this one it could only have gone from n minus 1 to n minus 1, right? So it can only go from minus 3 to 3. It means it cannot be greater than that. Okay, so if it is 4, then it can go until 3, and if the number was 100, then it could go until 99. Okay, so how can I do this? Yeah, I have in my mind there are solutions, but I need to think of optimal solutions, right? Or how to think about this, how to go about it. I don't know. First of all, let's think about brute force only. Okay, so I think what I do is like this, right? So for 3 numbers I do, for 5 I do 7 1 4, for 7 I do 1 4 5. So for n, what can I not do something like this? 5 7 1 and 4. First of all, add everything, and then no, adding everything does not work because I have to subtract so many things. Add last 3 numbers, add last 3 numbers. For this one also add last 3 numbers. Yeah, I think actually just sliding window should also work. Simple sliding window. I can just start from the last, from for this thing. So suppose if I add more numbers, okay, suppose k is equal to 2 only, then I could just do from this to this, whatever is the sum, and then just increment I, increment j, and calculate running sum by subtracting the first number and adding the second number. Similarly, keep on doing that, keep on doing that, keep on doing that, keep on doing that, and then at last, when I get to the end, j should begin from start again. So until I think this would work. Yeah, the sliding window, simple basic sliding window should work, I guess, because the sum will also be always like running sum. It will be linear, right? Because to find linear sum, I can just slide the window and subtract the previous last element, and I'll add the first element of the next window. And yeah, I can do that for both for both positive and negative k. If it is positive, then I will slide window forward. If it is negative, then I will slide window backward. Yeah, if it is positive, then I will just start from first I, but if it is negative, then I will just start from the last element, from I, so that this one. So if it was -3, then it would be something like this: j 3 5 7, and then do this. So it will be previous last numbers, right? Always. Yay, I think it worked. So if k is positive, then increase sliding window. If k is negative, if k is positive, then start filling with first number, and but if k is negative, then start filling with last number, and push sliding window backwards. Okay, and for both cases, I think if j, and here if j is greater than or equal to, if j is equal to, so if j reaches at the end, okay, if j is equal to code that length, it means it has reached end, then restart j to 0. Okay, and here if j is equal to 0, then restart. j to the end, j from the end. So if I'm doing this and if I reach here but j should reach there, then it should be code that length. Code that length -1. Okay, yay, this would work. And obviously I'll keep running some. So let running sum is equal to 0, and then if k is positive, if k is less than 0, then I should be equal to 0 plus 1. So if k is equal to 0, okay, then I should just immediately return new array of length, code that length dot fill with 0. Okay, or what I can do is so yeah, k is less than 0, I plus plus. So what I'm thinking right now is, should I create a new array or not? I think I should create a new array, right? Because if I am here and if I want to do this element, then if I replace this already, then this would not work. Okay, so let result is equal to new array that fill 0, suppose in the beginning, then return result immediately. Otherwise, if k is less than, then I equals to k is less than 0. If k is less than 0, if k is greater than 0, then it should be, if k is greater than 0, then it should be right, if k is positive, then start filling with first number. Otherwise, start filling with the last number, right? Last number means code that length -2. It should begin from there. And actually what I can do is, if k is greater than 0, then I can just say that I is equal to 1 and j is equal to code dot length -2. Okay, but if k is less than 0, in case if k is less than 0, then I must say that I is equal to not code dot length -2, I'm so sorry. In this case k should be equal to code dot length -2, but j should be equal to so for the first number, right, j should be equal to I plus 3. Zero, if this is 1, then 1 0 1 1 2 3 means just 2 plus 2. If I is here, then j should be here, right? It means -2, I -2. So yeah, and I also need to calculate the running sum. So how to calculate the running sum? I is equal to window start, I is less than window end. Okay. Okay. Yeah. So I've calculated. So this one is for when k is greater than 0, this is for k is less than 0. So here I've started with window start, window end, window start, window end, running sum, and then and now it will be start filling with first number and increase the sliding window. Now it will be now it should be like while I is less than now it should be while I is less than code that length, right? Until it reaches code that length. Or for if k is positive, then we will keep incrementing I, right, as less than code that length. But for if k is negative, then we will decrement. So while I is less than code that length, or I is greater than 0, we should keep on doing this. I think I should do and here. So what I should do here is so for this one, okay, so if it is positive, then it should be j, right? So 1 2 3. Now it is done for this one. So my code result, actually what I can do is running sum is already calculated, right? So result 0, it should be equal to running sum. Oh, result 0 should be equal to running sum. But but if k is less than 0, then result end will be equal to now since we have this here, right? So window start will be here. This will start the window, and j. So next we will decrement j and increment I. Right, so if k is negative, and here if k is positive, if k is negative and if k is positive. So if k is greater than 0, if k is less than 0, then we have to do two things, right? if k is greater than 0, then I have to do anyway. Running sum should be if k is greater than 0, then I have to then running sum result will be window start plus 1 is equal to running sum always, and I have to, I guess, if k is positive, suppose, so I and j starts here, so at another time I will increment here and j will also increment. So if it was 714 before, then it will be 142. Sorry, yeah, if it was 714 before, then it will be 1 4 and 2 next, right? So my window start will change, so it should be, I should first of all subtract window start, because I'm shifting the window, shift window forward, so I'm shifting the window, right? So running sum will be equal to code window, it will increment, decrement, and window start will print, and window end will decrease and also increment, and after window increment it should add the end one. Okay, subtract old window start, because we are moving the window forward, right? So I need to subtract that, and I need to add this, and result should be running sum. Okay, and but if this is the case, then since I'm decrementing like this, so I will be this one, so I should also do the same. Actually, I should do this, subtract the old window start, and window start minus minus here, because here I'm not shift the window backward, right? Because I'm shifting window backward here. Since I'm shifting window backward, so if this is I, then this will be my I, and J will also do J will also be minus minus. Window start plus 1 is equal to running sum. Okay, and so I will keep on shifting it until window start is less than code dot length, or keep on decrementing it until code is less than greater than 0. And at last return result. Yeah, this should import. Yeah, they also have done the same as me. Why are they doing start plus plus end plus? So that's why I do not understand. Like start will be. This is the case. This will be my start and this will be my end. Okay. But if I do start plus plus, then it will be this like this. So this is a good logic here. This one, code start percentage code length, code end plus 1% code length. What are they doing here? outgoing we are subtracting, and okay, so 0 1 2 2% is 3. It will end up, yeah. So this is a modulo. I need to understand how modulo works here. So if I understand how modulo works, then I can just do star plus plus and plus plus. I don't have to do all this by myself. I don't have to like do running plus minus. I mean, I don't have to, yeah, do minus minus and minus minus. Yeah, I can just do modulo and that should work. Okay, I understand this. Thank you everyone for watching. So I think the biggest takeaway for this one was, yeah, I was also thinking about it, but the biggest takeaway is when I have two similar functions, right? Like one was for when k positive and one was for k negative. Instead of writing verbose code, just write one function which will just write logic that will incorporate both. Yeah, and that is one thing, and another thing is use modulo operator for the circular array, so that I can just find the position exactly using modulo operator, and I don't have to do if if the index reaches the end, then restart to 0, or if the index reaches the beginning, then restart to the end. So I don't have to do that if I use modulo.